Okay, so this is number 8 on page 43. A horse trots away from its trainer in a straight line, moving 38 meters away in 9 seconds. So I drew a diagram here of it moving to the right 38 meters in 9 seconds. It then turns abruptly and gallops halfway back in 1.8 seconds. So from this point, I drew about halfway back, and that was 1.8 seconds and 19 meters. Calculate A, its average velocity, average speed, and B, its average velocity for the entire trip, using away from the trainer as the positive direction. So that initial, when he was walking away initially, when it walks away initially, that is what we are calling the positive direction. Okay, so we have to use our definitions of speed and velocity to calculate this. Our definition of speed, well, speed and distance are both scalars. They do not have a direction, and they are positive, and we just add them up. So in this example, the first distance was 38 meters, the second was 19 meters, and our times were 9 seconds and 1.8 seconds. So that will simplify to 10.8 seconds on the bottom and 57 meters on top. Okay, so if we put that into our calculator, we get about 5.3 meters per second, average speed. Okay, now if we try to calculate the average velocity, velocity is a vector. So velocity and displacement are both vectors, and they both have direction. So now we need to figure out the displacement. So we need to figure out this piece in orange here, because this is the distance from the start to the finish. Okay, so we can figure that out pretty easily here just by taking the total distance, 38 meters, and subtracting that 19 meters. So in this case, we subtract, why don't I do this in orange so we can see, this 38 meters minus the 19 meters, that's going to be our displacement, and our time is still 10.8 seconds. Okay, so now we get 19 meters was the displacement, and that is positive, right? If we look at the direction of this displacement, we started right here and we finished right here. So that is a positive displacement, and still 10.8 seconds. And now if we work this out, I think it'll be about half of the one before. We get about it's more than half. 1.7, we'll go with 1.76 meters per second. I'm not too picky on rounding, as long as your answer is close. Round to a few decimals. Okay, so we can see here that our velocity